Hi, Eric Rexted, University of St. Andrews. What I'm going to do over the next few minutes is I'm going to repeat the demonstration that I gave to those of you who attended the Advanced Distance Sampling Workshop last week, in which I showed you how to set up a project for working with density surface models. It's a special kind of project that has 5 data layers in the distance database rather than 4. I'm going to repeat those steps now. You can rerun this video as many times as necessary to catch all the steps. So I'm going to build a new project. It's going to contain data. It's going to be double observer, and it will have clusters in it. I'm going to set all of these units to something, meters, for the moment. And I'm not going to use any multipliers. I'm done with the wizards for the moment. I'm going to use a data wizard to bring in the data that I've already prepared, these text files. But I can't do that as yet because my data structure is incorrect. And so if you'll notice, in step 1A on page 109, I have some work to do before I can start importing. I'm going to rename this layer transect, and I am then going to delete the observation layer. That icon is the delete icon. I then want to create a layer called segment that is going to have transect as its parent. It is going to be of type subsample1. There it lives. I can now reconstitute the observation layer underneath the segment layer. There it is. All right. I've now completed step 1. Step 2 was to extract the text files themselves. You'll notice that I've already done that. I'm now ready to bring in the first text file with which I will use for which I'll use the import data wizard. Clicking right along, I'll tell it to go find the gradient design file. I have to bring this in highest level first to lowest level. So the design features that exist in the first file contain information about the transect and segment layer. No information about the observation layer. There it goes. Transect segment. Separate them with semicolons. Leave this unticked. Move to the next screen. Describe that the field name and the layer name are separated by periods. Note that there will be 4 new fields created. Each of those new fields will be created as type text. Text, 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 text. So the separation has been done, the parsing has been done correctly, but the field types have not been properly designated. So I will redesignate them as type integer. Now I'm ready to bring in the 180 rows from this data set, from this data file, that describe the design structure of this project. So there we are. So far so good. Step 3C asks that I type in the value 4800 for the size of my study area. Okay. Now I can bring in, using the data import wizard, I can bring in the second data file. This file contains information about the sightings themselves, and the sighting information or detections will live at the observation layer only, but parent segment level information is also contained in that file in the field called segment label. So that's what I'm telling distance here, that the input file contains a column at the segment layer called label. Semicolon separators, period between field and layer name. 5 new fields are going to be created, all as type text again, I warn you. So those need to be appropriately adjusted as type decimal and type integer. That's the appropriate categorization for these data. They're now ready to be imported via the data import wizard. 27 sightings in my data. In they come. I now have a data base inside program distance that respects my survey design, in which I had a single region, many line transects, the transects broken into segments, and the sightings assigned to various segments. I'm going to stop this video now. I'm not quite finished with doing all the preparation work I need to be able to analyze these data, but I've now reached the bottom of page 109, and I'm about to move on to part 5 of the practical. We'll do that in a moment.